All right. So let's talk about 6.4, equations involving inverse trig functions. This will kind of bring things full circle in chapter 6. We started off talking about inverse trig functions, then we talked about solving equations, and now we're kind of tying the two together, I guess, in some sense, although the concepts really are pretty closely tied together anyway. But there's really not much to say here in terms of strategy. Like, as far as strategy is concerned, I think it's pretty much the same sort of strategy as just solving trig equations in general. The main thing to remember is that, inverse trig functions undo trig functions and vice versa, right? So if you're seeing something like in this first example here, 2 arc sine x equals pi, well, arc sine x is the same thing as sine inverse of x, and if we want to undo sine inverse, we should just go ahead and take sine of both sides. Now, part of the problem here, though, is that before you can do that, you need to have the inverse trig function solved for first. So in this case, we need to get rid of that too. If we take sine of both sides the way it is right now, you can't distribute sine across this multiplication, 2 times arc sine x. So you have to get rid of the 2 first, okay? So we would divide both sides by 2. Now we can take sine on both sides. The sine cancels off the arc sine. You're just left with x on the left-hand side. So x equals sine of pi over 2. So now all we have to do is think about, well, what is sine of pi over 2? Of course, you could use your calculator for this, but you should be able to do this one in your head as well. At pi over 2, the y coordinate is 1, so x is 1. Okay, and that's it for that one. So here's another one, slightly more challenging perhaps. Let's do, and by the way, I'm following again with the example straight out of your textbook, because once again, your textbook takes kind of a different approach than I do, especially on this next one, right? So if you don't like my solution, you can take a look at your textbook solution and try to follow along with it instead. Okay, but let's do cosine inverse of x equals sine inverse of 1/2. I'll let you pause the video and see if you can try that one out. See if you can get it on your own. Okay. Here's my solution. We want to solve for x, and the only side of the equation that has an x on it is the left-hand side. The right-hand side is just a number, right? So we could change that into a number now if we wanted to. But since my goal is to solve for x, I'm just going to go ahead and say, I'm going to take cosine of both sides. So I get x equals cosine of sine inverse of 1/2. We did things like this back in 6.1. We did a bunch of these kinds of things. So that shouldn't be too much of a problem. Again, you could just plug this into your calculator and see what cosine of sine inverse of 1/2 is. If you wanted to do it by hand, which I would strongly encourage you to try it out by hand, it's a good exercise. Okay, but let's try this one out by hand, okay? So sine inverse of 1/2. I need to think of an angle such that sine of that angle equals 1/2. I'm thinking that the angle that'll do the trick is pi over 6. So I think this should be, this should be cosine of pi over 6. And now I have to go back and think, okay, so now what's cosine of pi over 6? Cosine of pi over 6 would be root 3 over 2. So x is root 3 over 2. And that's all there is to it. Okay. Let's look at another one. let's do arc sine x minus arc cosine x equals pi over 6. Okay. Now this one is definitely a bit more challenging, I would say, than the first two. The thing that makes it challenging is that, unlike the previous problem where you had two inverse functions, but only one of them involved x, right? The other one was just a number. Here you have, again, two inverse trig functions. In fact, they're the same ones, sine and cosine, but they both involve x this time. So that's a little tricky. I'll give you a second to pause the video, see if you can try something out and figure out a solution to this problem. Okay, so here I go. So I'm thinking that in order for me to start being able to undo anything here, I need to isolate one of these things. And it doesn't really matter, I don't think, which one I try to isolate, but I just need to try to isolate one of them so that I can then do, either sine or cosine of both sides. If I do that in the format that it's written in right now, I'm going to take, let's say I decide to take sine of both sides. Then I'll have sine of sine inverse of x minus sine of cosine inverse of x, and that doesn't really help me with anything. Actually, let me say that again because I may have said it wrong. I would have sine of this whole thing, and I can't distribute that sine to both of these individual terms. If I could, then actually I would be in okay shape. But anyway, I can't do that. So let's try to isolate one of them. I'm going to go ahead and isolate this first term by adding arc cosine x to the other side. Okay, so now that I've done that, I can go ahead and take sine of both sides. And on the left-hand side, I get x all by itself. That's nice enough. On the right-hand side, now I have sine of arc cosine x plus pi over 6. So hold on a sec. Sine of arc cosine x plus pi over 6. I'm stumping myself. Let me look at what your book has to say when it gets to this point. Ah, yes, yes, yes. It applies a sum formula. Oh, that makes sense. Okay. Yeah, very clever. Okay, so let's see. If it's hard for you to imagine doing a sum formula on this, just remember that arc cosine x, since this is an inverse function, it takes a real number and it maps it back to an angle. So this is just an angle. We could call it theta, right? We could say here theta equals arc cosine x. And if theta is arc cosine x, then what we really have is sine of theta plus pi over 6. Right? And now you have some formulas for sine. You can say, you remember the sum formula, I don't know what letters we used, probably sine u plus v or something like that. And it was sine u cosine v minus, no. Ooh, I have to look up that formula too. It's, no, that's right. It's sine u cosine v minus sine u sine v. No. Let me try again. Sine u cosine v plus sine v cosine u. Yeah. Anyway, so I'm going to say this is sine u cosine v plus cosine u sine v. All right, there's the sum formula for sine. Of course, the cosine pi over 6 and the sine pi over 6, we can do those pretty easily. Cosine pi, oh, we just did this in fact, right? Cosine pi over 6 is root 3 over 2. So this is root 3 over 2 sine theta. Sine pi over 6 is 1/2. This is 1/2 cosine theta. Well, we still haven't finished solving for x though, right? So we've solved for x in terms of theta, but theta was something else in terms of x. Let's go ahead and make the replacement now. We can say x equals root 3 over 2 sine of theta. Theta is really arc cosine x. Plus 1/2 cosine theta. Oh, well, that one's not bad, right? The cosine and the arc cosine cancel. We just got x, right? And in fact, we could go ahead and move that 1/2 x. We can subtract it over to the other side. X minus half x would be half x. Arc cosine x. For that matter, we could move it. Actually, we could multiply through by 2 at this point and clear that fraction. So once again, we have x equals root 3 sine of arc cosine x. Now, what do we do about that, though? Right? What do we do about the sine of arc cosine x? Well, so again, right, I'm thinking of arc cosine x like theta. And I can draw a little picture. Now, arc cosine could be in quadrant 1 or it could be in quadrant 2. So I guess I'll look at both cases. All right. So if theta is in quadrant 1, remember cosine is adjacent over hypotenuse. So that means that y, we can use the Pythagorean theorem, say x squared plus y squared equals 1 squared. So y is plus or minus square root of 1 minus x squared. If we're in quadrant 1, it's going to be the positive square root. If we're in quadrant 2, it's also going to be the positive square root. So I guess it doesn't matter which case I use. Y is going to be positive either way, right? So we can say, all right. So this side is the square root of 1 minus x squared. And now I want sine of theta, right? Sine of theta. Well, sine theta would be square root 1 minus x squared over 1. Right? So coming back up to finish my problem up at this step, I would say, all right, so this equals square root of 3 times square root of 1 minus x squared. Or I could distribute the 3 and call it 3 minus 3x squared. All right, well, I'm still not done. Let me grab another piece of paper. So at this point, what I have is x equals square root 3 minus 3x squared. But I think I'm almost there now, right? because now I can square both sides. Remember, the goal is to solve for x, right? And we haven't done it yet. We do have x by itself on the left-hand side, but we also have an x on the right-hand side, so we haven't finished solving. We need to square both sides. Right? So I just squared both sides. Now I can move this 3x squared over here. And I get 4x squared equals 3. Divide by 4. And then take square root. Oh, that's going to be plus or minus root 3 over 2. Right? Okay, so plus or minus root 3 over 2. Now, since I squared both sides of the equation at this step, I really should plug these back in here to make sure that they're both solutions. In fact, I kind of suspect that negative root 3 over 2 is not a solution, right? Because if you if you plug in negative root 3 over 2, you get the statement negative root 3 over 2 equals square root of 3 minus 3 times negative root 3 over 2 squared. That's an issue, right? No matter what's going on in here, if the radicand is positive, the square root's going to be positive. If the radicand is negative, the square root's going to be imaginary. So you're not going to get negative root 3 over 2 out of this stuff, right? So I don't think that's a solution. We can check positive root 3 over 2, see if it works. So we want to know if this is true. Well, let's see. Root 3 over 2 squared, that would be 3/4. 3/4 times 3 would be 9/4. So we've got square root 3 minus 9/4. Well, 3 would be 12/4, right? So this would be square root 12/4 minus 9/4. That's square root of 3/4. And sure enough, if you distribute that radical, right, you get root 3 over 2. Okay. And there you have it, right? So our solution, our one and only solution, x equals root 3 over 2. Okay. And that's it for that one. Just in time, because I think my kids are about to walk in.